So with this question here, we want to prove that a prime number that is 1 less than a multiple of 4 can never be written as a square number plus another square number, i.e. p equals x squared plus y squared. I've written here x, y, and p are integers, and that p is prime. Now, in particular, we also know that p is 1 less than a multiple of 4, so we know that p is equal to 4n minus 1, where n is an integer. Okay. Now we need to think about possibilities for x squared and y squared. So we've got that 4n minus 1, essentially, is equal to x squared plus y squared. So we need to look at the possible cases for two square numbers being added together. So a number can either be a multiple of 4 itself. So let me just leave some space. So we've assumed that it can be done, and a number can either be a multiple of 4, so 4m, or it can be 1 less than a multiple of 4, or it can be 1 more than a multiple of 4, or it can be 2 more than a multiple of 4. This is one way in which we can classify different ones. And in particular, we need to look at the situations where we square each of these. So if we square this, we get 16m squared. If we square this term, we get 16m squared minus 8m plus 1. If we square this, we get 16m squared plus 8m plus 1. And if we square this term, we get 16m squared plus 16m plus 4. Okay, so in this situation, we have a multiple of 4. So 16m squared is a multiple of 4. So let's just say a different letter. I don't know, like 4. What letters have I not used? 4c. This one, the 16m squared minus 8m, that's a multiple of 4 because the 16 and 8 are both multiples of 4. And then it's plus 1. So it's like some multiple of 4 plus 1. And then the 16m squared plus 8m, well, that is some multiple of 4 plus 1. So that's 4e plus 1. And then the next one is just a multiple of 4 because 16m squared is a multiple of 4 because of the 16. The 16m is a multiple of 4 because of the 16. And the plus 4, that's a multiple of 4 because of the 4. So add them, you get a multiple of 4. So that's going to be like 4f. Now, these are the results of squaring, right? So these are the things that x squared and y squared could be. X squared could either be a multiple of 4, because we've squared each of these, or it can be a multiple of 4 plus 1. In fact, they're the only options. So what we essentially need is we want to add 2 of these so that you get 1 less than a multiple of 4. But you can actually never get that. Because either you can do this multiple of 4 plus a multiple of 4, but the multiple of 4 plus a multiple of 4 is just going to give you another multiple of 4, right? That's the same thing as 4 lots of c plus f. Another combination we can look at is a multiple of 4 plus a multiple of 4 plus 1. So plus 1 of these. But that gives you 4 lots of c plus d plus 1, like that. So that is also a multiple of 4 plus 1. But none of the situations, there's no possible scenario where you can get a number that is 1 less than a multiple of 4. Let's take the final case, the final important case, 4d plus 1 plus 4e plus 1, where that's the same thing as 4d plus 4e plus 2, but that is just, what, a multiple of 4, which is 4d plus e, oops, 4 lots of d plus e plus 2. So this is a multiple of 4 plus 2. But none of these gives you one less than a multiple of 4, or if you like, a multiple of 4 plus 3. A multiple of 4 plus 3 is also one less than a multiple of 4. None of them give you that. So that's where our contradiction lies. So yeah, a prime number that is one less than a multiple of 4 can never be written as a square number plus another square number. So as an example, a prime number that is one less than a multiple of 4 would be 31. 31 is one less than 32. 32 is a multiple of 4. You cannot find two square numbers that add up to give you 31. So there we go.